In this video, we will continue practicing solving triangles using the law of sines when we are given the ambiguous case. The ambiguous case is when we are given two sides and the non-included angle, side-side angle. As soon as you see that you have two sides and an angle, go ahead and start setting it up this way. Draw yourself a horizontal line like this, and draw yourself an angle like this. And take the one angle that you're given and put it right here in the angle. So 45. So this must be B. Now, put yourself a temporary side over here. So when you do it, you'll make yourself a dotted line to remind yourself that you don't know what it looks like. It's temporary. Now when I do it here for this video, I'm going to use an electronic line like this so that I can actually swing it around and stuff. In fact, maybe I'll make it dotted as well. Okay, there's my temporary line. Now, so with my temporary line in place, let's see. So if this is angle B, then this must be side B over here. So that means this temporary side is the 27. Okay, now the 28, the other side that we're given, should be this side of the angle. So I'm going to put the 28 right here. Now if this is side A, that means this must be angle A down here. That leaves angle C, which must be this up here. Okay, so again, when you are given two sides and an angle, put your angle right here and let one of your sides be the temporary side and the other side be right here next to the angle. Alright, leave the side on the bottom blank. Okay, so we have to figure out if we can make a triangle at all. If this side is too short to reach the ground, we will have no triangles. If this side just barely touches the ground, we will have one triangle. If it's a little bit longer than that, we could have two triangles because it could hit here and here. If we swing it around, boom and boom, we could have an obtuse triangle and an acute triangle. Now if it's longer still, then it's only going to make one triangle like this, because by the time we swing it all the way around, then we realize, oh, it's too big. We can't make another triangle because it doesn't fit. Okay, so we don't know yet. That's why we made this dotted and we put it on a hinge. So the way we can figure out what is going on is we need to figure out what the height is. Okay, so just for a moment, I'm going to drop this perpendicular line down and I'm going to call this height H. So let's do some calculations. So the sine of 45 degrees would equal opposite over hypotenuse. So that would be H over 28. If I were to multiply both sides by 28, so these will cancel out. That's going to give me the height. So I'm just going to put this in my calculator. I'm getting 19.799. Okay, so look, so the height is approximately 19.8. Let's say that for now, 19.8. So side B here, the side that is on a hinge, the swinging side, is 27. is that going to be long enough to reach the ground? Yes, it will be long enough to reach the ground because the height is only 19.8. It's about 20. This is 27, so it will definitely reach. So we will definitely have at least one triangle. Now, if it can fit on the inside as well as the outside, then we'll have two triangles. So obviously it fits on the outside. Will it fit on the inside? Well, yes it will, because this is 27, whereas this over here is 28. So because this is longer, alright, the side BC over here, also known as side A, because this is longer than 27, then that means that 27 will fit. So we're actually going to have two triangles. We will have an acute triangle that looks like this, and then we'll have an acute triangle that looks like this. So I'm going to go ahead and leave this one set up as the acute triangle for now. But I'm going to have to draw another triangle in a moment that is obtuse. Okay, so we have this triangle happening, and I'm trying to decide if I should erase this because it's just in my way is all. It's just in my way. So my other triangle is going to look like this. So here comes angle B again. So there's my angle B. So here's that 28 that we were discussing. But instead of having this side stretching out like this, I'm going to have it stretching inward like this. Okay, so this would be angle B, and now angle A is going to be like right here, and angle C would be here. And remember that this is 45. We know that. Okay, so these are the two different triangles that we must solve. We're going to have two different solutions. Let's solve this one first. Okay, so I'll make a little list up here. We need to find the measure of angle A is missing. We're going to need that. We're going to need the measure of angle C. And we're going to need side C. Okay, so ultimately we're going to have all that information in this box. Alright, and we will need the same information over here. So I'm going to go ahead and write that down as well. Okay, over here we will also need the measure of angle A, and we will need the measure of angle C, and we will need side C. Okay, so all of that will be in a box over here. So let's start with the acute triangle. So law of sines. So looking at the 45 and the 27, angle B and side B. This would be a great time to do the law of sines. So we can do the sine of 45 over 27. Okay, and I see that the angle A is across from the 28, so I could say this will equal the sine of angle A over the 28. So to get the sine of A by itself, I would have to multiply both sides by 28. Alright, so those will cancel each other out. So this gives me the sine of A equals all of this. Now, I don't want the sine of A, I want angle A itself. If I want angle A, then I'm going to have to do the inverse sine, and that will give me the angle out. So I need to do the inverse sine of all of this, including the 28. So I'm going to do the inverse sine of 28 sine 45 all over 27. And that should give me the measure of angle A. So I'm just going to put all of this in my calculator. And I think I'll show it this time. So I need the inverse sine, so I'm going to hit second sine. And then I'm going to need a fraction now, so I'm going to hit alpha y equals and enter. So 28 sine 45. So 28 sine 45 over 27. Okay, so I'm getting 47.163. Okay, so that's angle A. So I'm going to go ahead and put that in the picture too. So that's 47.163. Now, to find the measure of angle C, I can just subtract these two from 180. I'm going to do that off camera. Okay, I got 87.837. I'm trying to squeeze that in here as well. 87.837. So that just leaves side C that I need. Side C is this right here. So I can do the law of sines again. So I'm just going to put a little line right here. I'm going to use this same ratio that I had before. So I'm going to do sine 45 over 27, just like before, should equal the sine of angle C over side C. So I'm going to say the sine of 87.837 over side C. So I can solve this. I'm going to cross multiply. So that'll give me C sine 45 is equal to 27 sine 87.837. To get C by itself, I need to divide both sides by sine 45. Okay, so these are going to cancel out, so that'll give me C. So just put all of this in your calculator at once. I'm going to do that off camera. I got 38.157. Alright, so that's one solution. That's the solution for the acute triangle. Now let's do the solution for the obtuse triangle. Now, I cannot do the law of sines in order to find angle C like I did before. When we did the inverse trig function, the inverse sine, in order to find angle A, notice that it gave us an acute angle. Okay, so if I try to do the same thing and do the inverse sine to find angle A here, guess what? It's just going to give me that same acute angle again. It will not give me the obtuse angle. It's because of the restrictions. Inverse sine is only going to give you answers between negative 90 and positive 90. And since we're talking about angles in a triangle, they can't be negative. So we're only talking about angles between 0 and 90. We're only talking about acute angles here. So inverse sine is not going to give you an obtuse angle. So we need another strategy. And here's the strategy. It's the strategy of isosceles triangles. if I extend this out, okay, this is going to make an isosceles triangle. Remember, I'm looking at this side like it's swinging on a hinge. I could put it in this position or I could put it on the inside, but either way it's the same length. Either way we're talking about a length of 27, whether the 27 is here on the inside or whether the 27 is here on the outside. Okay, it's swinging on a hinge, 27 in either position. So what you need to understand is these base angles will be equal. So we can use what we found from the acute triangle. So we found that angle A, the acute version, is 47.163. Okay, so we find that this right here is 47.163. That means this other angle is also the 47.163. Alright, both of these are the same. So the obtuse angle is making a straight angle with this. Okay, see how this is a straight line all the way across and it's being split up into an acute angle and an obtuse angle. If the acute angle is 47.163, I should be able to find the obtuse angle by subtracting from 100. Subtracting from 180. So I'm just going to do 180 minus 47.163, and that should give me the obtuse angle. That should give me angle A right here. Alright, when I subtracted from 180, I got 100, well, you know what, let me put it right here first. I got 132.837. Alright, now I'm going to try to squeeze it in here. 132.837. Okay, I found the measure of angle A. Now I should be able to find the measure of angle C very easily. Okay, now I don't need this scaffolding anymore, so I'm going to erase this. Clean that up. So I found that. Now I have these two angles and I'm looking for the third angle. So I should be able to subtract these from 180, and that will give me the small angle C. So that's what I'm going to do off camera. Alright, that's giving me a tiny angle indeed. It gave me 2.163 degrees. Man, that's tiny. Okay, so I'm just going to draw a little arrow because there's not a lot of room. Angle C up here is 2.163 degrees. That just leaves side C that I have to find. And side C is down here. Okay, so I'm going to use the law of sines like I did before. So using the same angle that I have over there, the same ratio that we started off with, sine of 45 over 27. Okay, oh yeah, let's not forget this is 27. That's given to us. Alright, so the sine of 45 over 27 should equal, and now I'm going to use angle C and side C. So I'm going to say the sine of 2.163 over C. So I can just cross multiply. So along this diagonal I will have C sine 45, and along this diagonal I will have 27 sine 2.163, and then I can get C by itself by dividing both sides by sine 45. So these are going to cancel out. So just put all this in your calculator at once and it will give you C. I'm going to do that off camera. I am getting 1.441, which is a teeny tiny side of a triangle. teeny tiny angle with a teeny tiny side. This is a narrow sliver of a triangle when you think about it. But that's it. Alright, this is truly the ambiguous case where it turns out we had two completely different solutions based on the same set of information. Alright, that's why they call this the ambiguous case, because it could be either one, either set of information. Alright, that, even though we only did one problem, that is plenty long enough for one video. So I'm going to call it quits. I will see you on the next video.